presenting on behalf of my first author, Dr. Jane Mulligan. I am the Chief Technology Officer of Structure, foot landmark detection with Structure. So the Structure sensor, the latest one, the Structure Sensor 3, shown on top. They are usually iPad mounted, designed for robust and accurate 3D scanning, increasing adoption into healthcare applications, especially orthotics and prosthetics. Okay. The Structure SDK. So that's a comprehensive suite of tools for advanced 3D scanning and object tracking, mesh reconstruction and processing. So it's something that makes it easy for almost any developer create an iOS app and provide it with 3D reconstruction automatically. We have more than 4 million scans performed per year using that SDK, and more than 400 iOS apps available to date. It supports multiple sensors, not only the Structure Sensor 1, 2, and 3, but also Apple's TrueDepth and LiDAR sensors. Starting with SDK 3.5, it also has foot anthropometrics available in the SDK. What is foot anthropometrics? So that's a characterization measurement of foot shape. So 3D scanning technology can automate, improve the accuracy and objectivity of the assessments. But the challenge remains in defining features and metrics. Define what are the landmarks we're measuring. So in this diagram here, the landmarks are shown in yellow. Okay. And for each one of those landmarks, as I mentioned, there are multiple definitions. We define in detail in the paper, and references are provided for each one of those definitions. Okay. Metrics are shown in green in the diagram. How do we do ground truth measurements? So we started by using a realistic reference foot model. It's a silicon foot. Taking multiple measurements with calipers and rulers. We did multiple measurements, removed outliers, and we ended up with a best estimate of the ground truth by taking the average of the remaining points. We did a minimum of 5 scans with each one of the Structure Sensors 1, 2, and 3. Then 6 different iOS TrueDepth devices. iPhone 13, 14, 15 Pro Max, iPhone 16e, iPad Pro 11-inch, and I put 3rd gen and also M4. All scans are performed using the same app. We call it ScanDeck. And then we calculated all the same 9 landmarks I mentioned and 7 metrics that I mentioned. When you look at the variation of foot metrics, several factors, right? So there is sensor noise, also operator skills, reconstruction error, and there is also the anthropometric algorithm error. We looked at a synthetic foot model, so something without noise, without interference of sensor accuracy or operator variations. And yeah, we do see quite a bit of variation for arch height and the anterior transarch length. But in all cases, those are within a fraction of a millimeter. So next, we are comparing results that we get by looking at structure sensors. We have generation 1, 2, and 3 compared to TrueDepth measurements. Do provide you with data consistency across measurements and across sensors. And you see additional improvements going to the latest, more robust Structure Sensor 3. If you look only at TrueDepth-based reconstructions, you can see variation from device to device. So you see that some devices are better than others. iPhone 16, for example, more noise. We do know that different generations of iPhones, we have variations in the baseline distance between the projector and the IR camera. We see Apple reducing the pixel pitch in their IR camera. We also see a variation from iOS to iOS. We have aggregate results, so combining all sensors, just looking at all metrics altogether. We demonstrated good precision even though we are looking at a wide variation of sensors, we are seeing results that are within plus or minus 5 millimeters with minimum variability. The foot length, perhaps the most important metric, we have a median value close to 1 millimeter. The metatarsal girth, as I mentioned in the beginning, is the one that has the largest variation, so it is most challenging to measure. Using the newer structure sensor, we see an RMSE of 0.28%. automated foot measurements using Structure SDK, Structure Sensor, and we get a medium results that are within plus or minus 5 millimeters. That in the future, we plan on extending. We are not going to stop a foot. We are already looking into face measurements. And in fact, I'm showing here an example of work done in collaboration with Smith Optics, in which they have an app available today that allows you to scan your face and have custom-made goggles.